Before we start this video, I would like to apologize and say thank you to Mr. Ribano for giving us opportunity to fill in the missing topics to our report. And I also apologize to my classmates because of missing topics from my report. So let's start. This video contains explanation of decimal number in fraction and its conversion to different number system like binary, octal, and hexadecimal. Decimal fraction to binary conversion. So let's try to convert 21.1 in decimal form to binary. So first, let's divide this 21 into 2. So 21 divided by 2 is equal to 10. Remainder is 1. So 10 divided by 2 is equal to 5. Remainder is 0. So 5 divided by 2 is equal to 2. Remainder is 1. Then 2 divided by 2 is equal to 1. Remainder is 0. 2 divided by 1 is equal to 0. Kaya titigil na tayo dyan. Ang magiging sagot natin, we will write our answer from bottom to top. So let's write it like this: 0, 1, 0, 1, 0, 1. Let's start with the decimal. The first thing we need to remember, if we divide the whole number by 2, we need to multiply the decimal number into 2. So 0.1 times 2 is equal to 0.2, and the remainder and the whole number rather is equal to 0. We will multiply again our answer to 2 until we get 0 equal to 0. So let's try it. 0.2 times 2 is equal to 0.4, and again the whole number is equal to 0. 0.4 times 2 is equal to 0.8. Again the whole number is equal to 0. This time 0.8 times 2 is equal to 1.6. Whole number is 1. Let's write it down here, 1. And we will only multiply its decimal to 2, not the whole 1.6. So 0.6 times 2 is equal to 1.2. Then let's write again the whole number, 1. Then 1.2, or rather 0.2 times 2 is equal to 0.4. And 0.4 times 2 is equal to 0.8. We notice that the pattern will repeat, or from 2 to 4, 8, it will just repeat. So let's stop right here. Then we will write our answer again. This time we will write our answer from top to bottom. Then our answer will be 1, 0, 1, 0, 1 point 0, 0, 0, 1, 1, 0, 0. So let's recall what we've done here. We separate its whole number, the 21.1, we separate the whole number to its decimal, then divided it by 2. Then 21 divided by 2 is equal to 10, and so on, so on, so on. Then we got this answer, 10101. We wrote this number from bottom to top. And to its decimal, the 0.1, we multiply it by 2. Unlike the whole number, we divide it by 2. We do here the opposite of it. So I multiply it by 2. Then 0.1 times 2 is equal to 0.2. And we wrote the whole number of the answer, and we find it 0. Then let's do the same process until we got the answer 0 here. And we notice that the pattern repeated. So our final answer is 10101.0001100. So let's have another example. Let's convert 43.167 in decimal form to binary. So again, let's separate this whole number to decimal and divide it by 2. 43 divided by 2 is 21. The remainder is 1. Then 21 divided by 2 is 10. The remainder again is 1. Then 10 divided by 2 is 5. The remainder is 0. 5 divided by 2 is 2. The remainder is 1. Then 2 divided by 2 is 1. Then we stop here. And we got this answer. We will write our answer from bottom to top again. So we write it as 1, 0, 1, 0, 1, 1. And let's move on to its decimal. Again, we will multiply this 0.167 to 2. And we will get the answer 0.334. Then let's write what is whole number. So 0. We'll consider this 0. Then multiply the answer by 2. 0.334 times 2 is equal to 0.668. We will consider again the 0 here. 0. Then multiply this 0.668 times 2. Then we got the answer 1.336. Then we will consider this 1. Multiply, and let's multiply only its decimal. So 0.336 times 2 is equal to 0.672. It seems to be, it will be never ending. So let's try. We got answer 0. So let's try if we'll get the answer 0. But if no, let's stop here, right there. So let's try to multiply 0.672 times 2. Get the answer 0. But our answer is 1344. And we'll consider this one. So obviously, it is never ending. So let's stop right here. And unlike this one, our answer will be written from top to bottom. So our answer is 00101 in binary. Decimal fraction to octal conversion. So let's try to convert 35.45 in decimal form to binary form, rather octal form, or base 8. Let's write down here the 35. We need to divide it by 8 because octal is in 8, base 8. So 35 divided by 8 is equal to 4. The remainder is 3. We couldn't divide 4 by 8. So we'll need to stop right here. And our answer is 43. 8. Then for fraction part, let's divide or multiply 0.45 times 8, because again our octal is in base 8, so we need to multiply it by 8. Then 0.45 times 8 is equal to 3.60. We need to separate the fraction to whole number, and again we will multiply only the fraction to its whole, to 8, and 0.60 times 8 is equal to 4.8. We need to remember this whole number because this will be our answer, or the fraction part to our octal conversion. Then we need to only to multiply the fraction part to 8. So 0.8 times 8 is equal to 6.4. Then 0.4 times 8 is equal to 3.2. Then 2, or 0.2 times 8 is equal to 1.6. Again, it seems to be never ending, or we couldn't find the answer 0 to, or our hint to stop. So let's stop right here. It is fine to only compute the fraction part, the first 5 digit of the fraction part. Then let's write our answer from top to bottom again. Then our answer will be 43.34663 and 1. So let us recall what we've done here in decimal fraction to octal conversion. We separate the integer number to its fraction number and divide it by 8. We need to divide it by 8 because our answer must be in base 8. So 35 divided by 8 is equal to 4. And we stop right here because 4 cannot be divided by 8. Our answer is 43 in base 8. So for its fraction, the 0.45, we multiply it by 8. The opposite what we done here. So 0.45 times 8 is equal to 3.60. Again, we need to remember or separate the integer to its fraction, and we only multiplied the fraction number to 8. So 0.60 times 8, 4.8, and so on and so forth. We got the answer 34631, or this 34631, and our final answer is 43.34631 base 8. So let's have another example. Let's convert 239.563 in base 10 to octal number, or base 8. Again, we need to separate the integer number to fraction number. So let's separate 239 and divide it by 8. Again, we need to divide it by 8 because our answer must be in base 8. So 238 divided by 8 is equal to 29. Then the remainder is 7. Then 29 divided by 8 is 3. And the remainder is 5. So our answer is B, 3 2.57 in base 8. Then let's go to the fraction number. Then let's multiply this 0.563 to 8. Again, we need to multiply it by 8 because our answer must be in 8 or base 8. Answer is 4.504. We separate the integer number to fraction number because we will use this as our answer. And again, multiply the fraction number to 8. So let's multiply 0.504 times 8. The answer is 4.302. 0.302 times 8. The answer is 0.256. Then let's separate again the 0 and multiply the 0.256 to 8. The answer is 2.048. Let's consider these two. Then let's multiply again the 0.048 times 8 is equal to 0.384. Then let's consider this 0. We stop right here because we get the first 5 digits of the fraction number. It is fine because we couldn't get the 0 and it will be never ending if we try to compute for it. Then let's write an answer. Let's write an answer from top to bottom. Then our answer will be or must be 357.44020 base 8. So let's convert decimal fraction to hexadecimal. Let's try to convert 7 to 5.25 in decimal to hexadecimal or base 16. Again, we need to separate 7 to 5 or the integer number to decimal to fraction. Then 7 to 5 and divide it by 16. Again, we need to divide it by 16 because our answer must be in base 16. So 7 to 5 divided by 16 is 45. The remainder is 5. And 45 divided by 16 is 2. Then the remainder is 13. Our answer must be 2d5. Why? Because if we convert this 13 into hexadecimal, it must be d. We refer to this table. Then t is A, 11 is B, 12 is C, 13 is D. Then we go to the fraction part of this number. So let us multiply 0.25 to 16. Again, we need to multiply this number or the decimal number to 16 because our answer must be in base 16 or hexadecimal. And we get the answer 4. Then separate the integer number to decimal or the fraction. Then we got 4. And we multiply the decimal number or the fraction number to 16. Our answer is 0. This part we need to stop because we already got the 0. Then we will write our answer from top to bottom. Then our final answer must be 2d5.4 in base 16. Let us recall what we've done here. We separate the integer number to fraction and multiply the integer number to 16. Then our final answer is 2D 5 because 13, where if 13 is converted to hexadecimal, it is equal to D. Then 2 decimal, you multiply it to 16, you got the answer 4. Already stopped and didn't get the first 5 digits because we already got the 0. Then our final answer is 2D5.4. So let's try to answer another example. Let's convert 10 20.1 in decimal form to binary, or rather hexadecimal form, or base 16. So again, let's separate the integer part, 1020, then divide it by 16. And the answer is 63, and the remainder is 12. Let's divide it again by 16. 63 divided by 16 is 3. The remainder is 15. Then we will stop right here because 16 divided by 3 divided by 16 is 0. Then our answer is 3FC. Again, we need to consider this table to convert these two numbers, 12 and 15, to hexadecimal. To convert it, 12 is equal to C, then 15 is equal to F. So our answer is 3FC. Then let's go to the fraction part, the 0.1. Let's multiply it to 16 because we need an answer. We need to multiply it by 16 because our answer must be in base 16. So our answer is equal to 0.1 times 16 is equal to 1.6. Let's separate again the integer part, the 1. Then multiply the fraction part to 16. Our answer is 9.6. Multiply it again. Separate again the integer part and multiply again the decimal. 0.6 times 16 again is 9.6. 0.6 times 16 again is 9.6. It seems to be never ending because our answer has a pattern and it will be repeated if we continue this. So let's write it down from top to bottom. Then our final answer must be 3FC.1999 base 16. Here's our final answer. Again, we need to consider this table to convert these two numbers, 12 and 15, to hexadecimal. To convert it, 12 is equal to C, then 15 is equal to F. So our answer is 3FC. Then let's go to the fraction part, the 0.1. Let's multiply it to 16 because we need an answer. We need to multiply it by 16 because our answer must be in base 16. So our answer is equal to 0.1 times 16 is equal to 1.6. Let's separate again the integer part, the 1. Then multiply the fraction part to 16. Our answer is 9.6. Multiply it again. Separate again the integer part and multiply again the decimal. 0.6 times 16 again is 9.6. 0.6 times 16 again is 9.6. It seems to be never ending because our answer has a pattern and it will be repeated if we continue this. So let's write it down from top to bottom. Then our final answer must be 3FC.1999 base 16. Here's our final answer. I hope you understand my explanation. Thank you.